I'm Eli. This is Ethan. This is our project. It's called Empowering Voices Awareness in AAC. So the company we worked with is the Department of Special Education here at UNL. One of the statements that's on their website says that they aim to improve the learning outcomes of children and adults with disabilities. And the problem that we were trying to solve with our project is that AAC devices have a limited capability to express the user's emotion. And AAC, that means augmentative and alternative communication. And all that is would be like an iPad or something that anybody with a speech disability would use to talk for them. So they'd be pressing buttons, building a sentence, and the iPad would talk for them. That's an AAC device. And our project was working on giving those devices capabilities to detect emotion.
As for our sponsors, we had Kevin Pitt from the Department of Special Education. He was our overall sponsor and contact for this project. We also received help from Sierra and Chris. Sierra is an assistant professor at the university, and Chris is a senior vice president at Smartbox. Smartbox is a company that makes a software called Grid, which is one of the AAC softwares used by a lot of children.
And then our faculty team is our project manager, Mel, our tribe lead, Trudy, she's here today, and our coach, Bethany, she's also here.
As for the team, we have Eli over here. He was our development manager, and also our team lead. We also have Jack, who was our product manager. Our product specialist was Morgan, and then me, Christy, and Sabrina were the developers on the team.
So to go over the problem we were tackling, AAC devices have limited capability for emotional expression. And some of the traits that AAC devices have that lean into this limited capability is, first of all, AAC devices are just inefficient and impractical. So to elaborate on that, if you could picture using an AAC device yourself, you're having a conversation with your friend, and you have to, anything you want to say, you're going through this device to say it, right? So say your friend is telling you a story and you're feeling excited or sad or any sort of emotion, and now you have to scroll through a whole list of words to kind of find words that will convey your emotion. You can see how that would be a little bit annoying. Maybe it's a fleeting emotion, and by the time you find the words, like, you're not even feeling it anymore. So that's one issue that limits the capabilities of these devices. Another issue is that the devices currently are incapable of detecting the user's emotion. They're just ignorant to the state of the user. Unless the user manually inputs that emotion, maybe that could work. But many of the common AAC devices just are unaware of what the emotion's feeling, or what the user is feeling. So our app solves these problems using a few different things: facial emotion detection, vocal emotion detection, and then calibration and real-time training. Those are the 3 big points, and we're going to get into all of those things next. This picture, that is kind of what an AAC device would look like for the user. So you see all those words, they'd be building sentences, hitting those words, and you can see how it could be frustrating scrolling through a whole bunch of those, trying to find one appropriate to your emotion.
In case you haven't seen our app, this is what the home screen looks like. So we've kind of divided it up where the left side of the screen is all of our AI stuff, and the right side of the screen is kind of to mimic what a AAC device may look like to an end user. Our app is more of a proof of concept, so we didn't have a ton of focus on the UI, so that's why we chose to divide it this way. So as mentioned before, we have the facial model, which is in the top left corner. As a user, you'd have to turn on and off this model just to give the user the control whether or not they want it on. And then same with the acoustic detection, which we have in the bottom left. On the right side, we see the predictions of the model. So we have different emotion buttons. As a user, if the model is detecting the incorrect motion, you can click one of these buttons to select it manually. And then this will get into our personalization, which we'll talk about later. And then you can also build your sentence in this makeshift box that we have down here.
So to talk more about the actual emotion detection that our app does, we use AI models to do that. The facial emotion is detected through a model called DeepFace. It just takes the pictures that your device captures, sends it to this deep face model, and deep face predicts the emotion based on that. Deep face was an open source model that we found online. It's trained by Facebook. They had millions of photos, and so deep face was a pretty reliable model that we found. As far as acoustic recognition goes, we made a model ourselves. I say we, Ethan made this model himself, and that predicts emotions based on what your device picks up through your microphone. So if it's hearing you, and keep in mind that our users are not verbal, so they're not talking, most of them aren't. So they won't be saying words, but maybe they'll make noises of excitement or sadness, and the device should be able to pick that up and help detect the emotion through those sounds. And yeah, see here it says lexical and non-lexical. That's lexical means related to words, non-lexical is not. So we trained it on both audio, words, and then sounds.
Additionally, everybody expresses their emotion differently, which was one of the big challenges of this project. So to try to combat that, we implemented the ability to personalize a model. So when you open our app, you'll be asked to create an account. So this is what that screen is. Once you create your account, you have the option to go through a calibration sequence. This is similar to setting up facial recognition for your phone. That's where we got the inspiration from. It'll prompt the user to act out different emotions, and then we take those results, give them to the models, and the models will train on that data to hopefully better predict you. Additional to this, we have real-time learning. So as you use the app, say it detects that you're sad, but you're actually happy. So you press that happy button. Our app saves that data, and it'll send that to the model as well. So as you use the app, the idea is that over time, it gets better at detecting you.
So to wrap up our project with just some values that we brought from it, some lessons we learned. Our first one, we have sourcing and filtering quality data sets. This turned out to be a lot trickier than we had imagined. First of all, the first data sets we were looking at were facial data sets. So, tens of thousands of pictures of people's faces, each tagged with an emotion. And at first, we would give them to our model and just train on it. And we were getting some weird results. So we're like, okay, well, let's go look at these pictures and see what's going on. And we found quite a bit of just terrible photos, like people wearing masks, something that just doesn't even make sense to detect an emotion from. Pictures that are obviously like edited, like there's this old guy that was edited to look like a tomato. And these were like in like popular databases, and I don't know, they were like recommended databases, and still it was not great. And then for the acoustic stuff, it was difficult to find acoustic databases that weren't people talking. Just making noises with emotional intent is not a common thing. If you think about trying to do it yourself, that's not easy to do. So it makes sense that they're hard to find online. So that was a struggle to find. So yeah, we worked a lot with data sets over this project, and we learned a lot about them. Another lesson that we learned was just using version control like GitHub to collaborate. We had a team of 6. That's a lot of people working on the same code. So GitHub was important to make sure that we were all on the same versions and not having merge conflicts, although we had merge conflicts every week. Connecting a complex, multi-threaded AI backend to a simple, easy-to-navigate graphical interface. So you saw the app earlier, and we tried to keep it as simple as possible for the kids that will be using it. But the things going on in the backend, the AI running on separate threads, was very complex. So it was a bit tricky to figure out how to get all this stuff to connect, because there's so much going on in the backend, and we just want it to be digestible up front. We crammed a whole bunch of buttons on the screen, and it ended up working pretty well, but it was tricky to figure out how to find that balance between complexity and simple. Some value that we gained through this project, the value that our project possesses is it's an application that is versatile and customizable and has an approachable child-friendly interface. We had a lot of emphasis on trying to make this easy for kids. This summer, we plan on using it with kids, so we really wanted to make it easy for that. And then some more value that it brings is this just serves as a proof of concept for future development in AAC. This is pretty leading edge. There's not a lot of AAC devices out there, or maybe any, that detect emotion like this. So this is a really cool opportunity for us to bring something new to the table and maybe help get funding for the Department of Special Education to get further research and just make these devices better for their users. So we're really happy that we could do that with our project and actually bring some value to, and we all love that it was helping kids. We think that's cool. But yeah, that's kind of what we learned.